Uh, Hello, everyone. Today, in my final presentation, I'm going to talk about FL and the survey on enabling technologies, protocols, and applications, federated learning. My name is Iman Bekanarov, and today I will be talking about this topic for my final presentation. Okay. This paper provides a comprehensive study of federated learning with an emphasis on enabling software and hardware platforms, protocols, real-life applications, and use case. Federated learnings can be applicable to multiple domains, but applying it to different industries has its own set of obstacles. FL is also known as collaborative learning, where algorithms get trained across multiple devices or servers with decentralized data samples without having to exchange the actual data. This approach is radically different from another more established techniques such as getting the data sample as getting the data samples getting the data samples uploaded to a servers, or having data in some form of distributed infrastructures. And also federated learnings on the other hand generates more robust models without sharing data, leading to privacy-preserved solutions with a higher security and access privilege to data. And also, this paper starts by providing an overview of federated learnings, and then it gives an overview of technical details that pertain to FL enabling technologies, protocols, and also applications. Compared to other survey papers in the field, uh, our our objective is to provide a more thorough summary of the most relevant protocols, platforms, and the real life use case of FL to enable data scientists to build better privacy preserving solutions for industries in critical need of FL, and also provide an overview of key challenges presented to the recent literature, and provide a summary of related research work. And moreover, we explore both the challenges and the advantages of federated learnings and present detailed service use case to illustrate how different architectures and protocols that use FL can fit together to deliver desired results. Okay, and the next page. Here, there's some introduction. FL is a newly introduced technology that has attracted a lot of attention from researchers to explore its potential and applicability. And FL simply attempts to answer this main question: can we train the model without needing to transfer data over to a central location? Within the FL framework, the focus is geared towards collaboration, which is not always achieved through standard machine learning algorithms. And also, in addition, the FL allows the algorithms used to gain experience, which is also something that cannot always be guaranteed through traditional machine learning methods. And federated learning has been employed in a variety of applications ranging from medical to uh, IoT, transportation, defense, and mobile applications. Its applicability makes FL highly reliable, with several experiments having been conducted already. Despite FL's promising potential, FL is still not widely understood regarding some of its technical components, such as platforms, hardware, software, and other, regarding data privacy and data access. Therefore, our focus uh, our focus is in this our focus in this in this research in this paper is to expand on FL's technical aspects while presenting detailed examples of federated learning based architectures that can be adapted for any industry. And there's also a figure of federated learning architecture. As you can see, there's a data owner 1, data owner 2, data owner 3, and it is the updated model. And this figure is representing the general architecture of FL. And yes, that's the simple architecture of FL. And related works, it can be deep learning, machine learning, and also federated learning. And FL is often compared against distributed learning and parallel learning and deep learning, as I told. While the FL remains a new topic, there have been several related works such that do examine FL in detail. And first, let's talk about deep learning. FL is often compared to deep learning techniques because DNNs, deep neural networks, have been used for various purposes and often have promising results. And comparisons of deep learning models have been made regarding the protection offered, performance, resource, and etc. And both aspects depend on architecture, which is something FL also needs to be successful, set for various purposes and goals, and also often have promising results. And overall, the authors do an excellent job of diving into deep learning, but they do not dive into enough detail about FL. Is next here. There's a machine learning, and the article by discuss by this by discuss how cost and latency still plague traditional machine learning methods. Both problems are difficult to solve because the data itself is highly distributed. This poses problems with traditional machine learning methodologies regarding computation and communication. For instance, if the data spans multiple locations, data centers, communication can very easily overwhelm the limited bandwidth. That's the bandwidth. And while machine learning does allow us to process data to reduce the latency, and it can still lead to high monetary costs for communication because the data can be highly independent and highly distributed. This can create some interoperability issues that machine learning algorithms using the data because the data could end up because the data may end up not being usable. And while the article does highlight the drawbacks of traditional machine learning methods, that is not the primary focus of our presentation or the of the paper. And here the third option is federated learning. And FL systems face challenges such as assumptions being unpractical, efficiency, and scalability. It should be noted that when designing FL systems, it seems that two main characteristics are rarely considered in implementation, which is heterogeneity and autonomy. And also the heterogeneity refers to diversity systems that use more than one kind of processors or cores to achieve optimal performance and energy uh, energy efficiency. In the context of machine learning and FL, the heterogeneity concerns data privacy and task requirements. And the next page. Here, architecture and platform of federated learning. And federated learning comes with quite a few architectures and platforms. The table summarizes the various architectures and their focuses. For example, as you can see here on our table, there are the architectures, the list of architectures and benefits, and also the main focuses. And yes, you can see from my table here everything. For example, the architecture FTL with the benefits higher accuracy, encryption, and the focuses prevents accuracy loss, and so on. And vertical and horizontal federated learning architecture. Here, the vertical FL is also known as feature-based federated learning. The left side figure illustrates the workflow of vertical federated learning. With vertical federated learning, what we are doing is collecting and grouping these various features. Then we need to calculate training loss so we can form a model that contains data from both entities collaboratively. And also under vertical federated learning, each entity has the same identity and status. In this framework, the adversary can only learn data from a compromised client. With the vertical FL architecture, the architecture is less explored, and then the horizontal federated learning architecture. And there's also the horizontal federated learning is where features are similar but vary in terms of data. Interestingly, there have been examples of a horizontal FL framework being proposed. One example is where Google proposed a horizontal federated learning approach for managing the Android mobile phone updates. From a more technical perspective, horizontal federated learning assumes there are honest consumers and security against the server. So just the central server can modify consumers' data with horizontal federated learning architecture. There are an X amount of elements of similar structures that learn a model with the 8 servers or parameters. The training process of horizontal federated learning shown in above the right side figure of my presentation on this page. Yes, and we go to the next page. The framework of federated transfer learning and MMVFL. Here, in addition to the horizontal federated learning and vertical architectures, another architecture for federated learning is called federated transfer learning. It's FTL. With FTL, it's used to utilize data from a different source for training the models with and with transfer learning. It involves learning a common representation between one entity's features and reducing error in prediction. The prediction, the labels for the targeted entity. And the FTL is shown in above the left side figure on my presentation on this page. And also the multi-participant, multi-class vertical federated learning framework is shown in above the right side figure here on this page. On the right side, as you can see here, BFL server, and also MMVFL enables labels sharing from its owner to other participants in a manner of privacy preservation. One problem with using horizontal FL architecture is the assumption that data sets from different entities have the same feature, or yet they may not similar to the same samples ID space. And that is not always the case, unfortunately. So the proposed framework is meant to elevate that setback. And with the MMVFL framework, the goal is to learn multiple frameworks to complete different various objectives. And the reference are from this IEEE Explore website, as our professor mentioned on e-learning site. I took all my informations are from this website. And thank you so much for watching. Thank you.